So right, let's continue. Hope all can hear me. Right. So yeah. Um, then last week we learned C sharp as a um, but statically typed object-oriented programming language that runs on .NET framework. So what do we mean by a framework? A framework is a tool set, right? It has uh, a pre-built collection of libraries and tools to develop to develop applications, right? So, like, what do we code, right? Without reinventing the wheel, that means we in programming we do not build things from the scratch, right? Let's say we are building a system for a shop, right? So yes, we have to use a database, right? We have to connect with the database, right? So we are not writing from the scratch to connect with the database. So in the framework, they have given us that uh, libraries to connect with the database, right? Likewise, so it comes with pre-built libraries and tools to develop, let's say, web applications, uh, Windows application, mobile applications, likewise, right? So, so for different programming language, there are many frameworks as well. So, as example for Python, there is for developing web applications with Python, there is a framework called Django. Then to uh, so JavaScript, for the language JavaScript, there is frameworks like Angular and React.js. Right. At the end of this module, we are going to develop a web application using ASP.NET that comes with .NET framework. Let me share my screen. Right. So open Visual Studio. Right. Create a new project. Let's create a console app. Okay. Let's name it as lesson 2. So, um, can you remember how we define the variable? So, first we need to give a variable name, data type, say int, and variable name, let's say number 1, and the value, right? This is how we define the variable. So this is the data type, and this is called the variable name for the identifier, right? The class has a name, it's a program, and a variable has a called identifiers, and we have the value, right? So uh, what is why C sharp is calling as a statically typed programming language, right? So we have to specifically define what type of data we are going to store in this variable, right? This is an integer type variable, so we can assign values of the integer type, right? We can't assign characters, right? Right, which gives an error. Cannot implicitly convert string to int, right? That means this is an integer type variable, so we can keep integers, right? So um, May I ask why we have data types in programming languages? Right? Right. Tell me what are the primitive data types? We know primitive data types are numbers, characters, and boolean. Right. So you may ask, so why we consider numbers, characters, and booleans as primitive data? Right? Primitive data because we know the fundamentally computers are what? Computers are digital devices, right? They can only understand ones and zeros. Actually, what do we mean by one and zero? One means there is electricity. Zero means there is no electricity. So since computers are digital devices, they work on the binary number system. They can only understand binary, like, right? So using binary, we can represent numbers, right? Right. Let's say number 10, we can represent it in binary, right? Then uh, the computer scientists want to represent characters, right? So there we introduce ASCII character sets. So that's how they represent characters. Then obviously we can represent Boolean with 0 and 1, right? 1 means true, 0 means false, right? So that's why numbers, characters, and Boolean we consider as primitive data types, right? So using the primitive data types, we can represent other data, like let's say an image, right? An image is ultimately get converted into pixel. Each pixel is represented with uh, three uh, three colors like RGB, red, and blue. Those a video is a sequence of images, right? So those things you have learned. So that's why we consider numbers, characters, and Boolean as the primitive data type. Right. Right. So then we have like let's say numbers. For a number, we have different data types. Either right. We have integers, double, unit, likewise. Why? Right? Because when we store something in the computer, we have to consider about the memory efficiency. Like let's say the maximum value we get is number 10, right? But we allocate memory to store 1,000, right? That's the waste of our memory, right? So when we design programs, when we develop programs, we have to use our memory efficiently, right? Our program has to be memory efficient, right? So that's why we have a different uh, data types like integer, double, unit, likewise, and char, string, likewise. So then we learn that this is as uh, identifier. Identifiers can't be uh, keywords. So that means keywords are what? Keywords are reserved word for the programming language. Right. So that means I can't create a variable as integer from the integer type, right? My variable name can't be integer, right? This gives me an error. So also there is some naming conventions like I can't start my variable name with the number, it gives me an error, and it can only start with a word or a or underscore character, right? And I can't uh, have special characters uh, in the variable name, right? Like right. So if it is one number, I can use an underscore, right? So those are the naming conventions, right? Um, right. So now we have learned about variables. Now I want to discuss with you about data structures, right? So uh, let's say for an example, I have um, I want to create a program to store student marks for IT subject. Let's say um, let's say subject is IT, and I have let's say three students. Let's say five students. I have five students, and I want to keep the mark of the student. So uh, let's say uh, int student once student once mark as 10, right? Uh, int student whose mark as 9 out of 10, he got 9. Student is marked as, let's say, this is how we, like, in a, if we try to create variables for each student marks, this is how we should uh, create it. So, what if uh, we can keep in one everything in one? So that's where the data structures come. So data structures are is a way organizing and storing data uh, that can access and modify efficiently, right? So uh, it, using data structures, we can uh, keep multiple values in an organized manner, right? Okay. So first data structure we are going to learn is array. C sharp, we define an array like this, right? I want to create array of integer type, square integer, then square bracket, in the array name, let's say students marks for ID, and I am using new integer. I have five students, right? Okay, right. So in this array, I can store five values. Uh, Array is like this. It's we keep everything in consecutive memory locations. The first element of the array will have the index of 0, then 1, 2, 3, 4, right? In C sharp, an array have a fixed size, right? So, um, right. So how we keep these things uh, in array? So each element in the array has an index starting from 0, right? So we can assign values for 10, 10, uh, So, so these values will be stored in contiguous memory locations. Then, so therefore, we can use but a for loop. We can use a loop to iterate through that array and get the output, right? So for I equal 0, then until I become less than the end of the array. We can get it by array length until I become less than the array length. That means until the end of the array, uh, I want to print so dot write line the value of that mm, array element, right? Then I want to increment the I, I plus plus, right? Then at the end, I want to say console dot read key. Hmm, right. Okay, so let's run this. You can see we get the output, right? So rather than keeping the values in uh, individual variables, we can use an array to store data in a store values in organized way. So we can efficiently retrieve data and manipulate that data. So in C sharp, we can in C sharp array we can array have a specific data type. Means this array can only have integer type data and it has a fixed length. So uh, right. So rather than writing this loop like this, I can simply write for in number in each for each number uh, in student marks for IT array print number. So these two are equal, right? So I will comment this. And we get the same output, right? So rather than writing the for loop like this, you can write it like this. Okay, right. Okay. So I told you that uh, in uh, in C sharp, we an array has a fixed length, right? So let's try to do something like this. Even though our array has five, uh, it has a length of, it has the length as five. Let's try to uh, add a new value, right? So uh, let's say 5. Let's assign a value as 6, right? Right. You can see there is no error. Now I try to print everything. Right? There is no error. Let's try what will happen. Okay. Right. It gives me an error. You can see there are two type of errors. Right. I will stop this, and we know in uh, in C sharp every uh, uh, command, uh, each command has to be end with a semicolon, right? If I did not put the semicolon, it gives me an error, right? Gives me an error uh, here. It's saying semicolon is expected. So these are called compiled errors, right? So compiled errors. So before running the program, we can we get that error. I'm telling the computer to catch that exception, print the message, right? Say stop message, right? So this is called exception handling. So when we write programs, we have to, like, we can get runtime errors. So that means uh, when we try to compile and when we run the program and it does not show us any compile time errors, the error occurs in the runtime, right? So we have to prevent those scenarios. Those are called like exception handling, right? So when we program, we expect computer to do something. Like in this case, I'm expecting to add an element to this array. Can't do it. The computer can't do it because in C sharp, arrays has a fixed length. Right? So it gives me a runtime error. So that is not I'm it is something not I'm expecting, right? So that's an exception. So I have to handle it, right? Let's say uh, when we creating systems, so with runtime errors, the program gets stopped, right? Right. So when we develop real world applications, even though when we get an exception, the program should not stop, right? So let's say we have a login management system, right? Login system. Let's say user enter the correct username and the password. So what is the expected behavior? The user should be able to log into the system, right? That is our expected behavior. But let's say we have a network error. Like we have a network issue, so the system is unable to connect with the database, right? So, uh, so then what will happen? We will get a runtime error. The system will try to connect with the database, but with the network issue, the system will not be able to connect with the database, right? So that is an exception that can happen, right? So rather than showing the user the error or the system breakdown. So we should redirect him to another page or something showing there's a uh, error in the system. Try again later, right? So that's how the cycle. That is called exceptions handling, right? We should properly handle exceptions when developing system, right? So now let's try to uh, run this program again. Then let's see the output, right? Now we get an error exception as index was outside the bound. Index was outside the bounds of the array, right? That is the exception we get. So the program didn't get stopped. We get this exception, right? So uh, for uh, in C sharp, arrays has fixed length. So uh, if we want to, let's say, I don't know how many students are there. That kind of scenario, we have a data structure called lists. So uh, in a list, we don't need to define give the length, right? So we can define a list like this. I want to create a list, right? This is the integer type, and let's name it as student. Students marks for ID for ID, and using new keyword, I'm creating a list, and let's say initial values are but 10, 9, 8, 10, 7, 10, 9, 8, 10, 7, right? Right. Uh, um, right. So now uh, uh, let's print the elements in the list, right? For is used for each int mark mark in students ID list. Um, I want to print console dot guideline the mark. Okay, right, right, right. So I get the output. Then let's say I want to add another mark. So I can use student marks for ID dot add new value is 6. Okay. So can see lists do not have a fixed length. The uh, third type is dictionaries, right? So let's say I want to keep uh, the student name and his subject mark. So though in that type of scenario, we can use a dictionary. In a dictionary, uh, it will have the key and the and the value. So it will be stored as a key value pair. So um, we can create a dictionary like this. Dictionary with the key and the value. Right. This case, I will use mm, a student name as an value, and we will name this as and um, I want to create a new dictionary in um, then we can add values to this dictionary. Students student dot add. I can add the name and the value. So in this case, the name will be the key. Let's say Alice, the mark is 10. Using this data structure, we can create, we can keep a key and a value, right? Right. So let's say I want to print uh, the student's marks and the his student's name and his mark. So I can use loop for each key for each key value pair. Okay, key value pair is in the type of string and integer. The key is a string type of a value. In this case, the name is the key. It is string type. Then the value is 10. It has an integer type. So for each key value pair, there are entry in key value pair entry. For each key value pair entry in. So I want to print console dot write line. I want to print entry dot key and the entry dot value. Right. So let's run this. Right. I'm getting Alice, Mark is 10, John 9, Alexa 8, Bob 10, Charlie 7. So what are the data structures we learned? Why we needed data structures? The variable is like a container which created in the in our RAM. Each variable has a data type and it can only hold a one value. So uh, we want to keep multiple values in a organized way. So there we have data structures. Like first data structure was array. Uh, because it's getting created in contiguous memory locations, uh, we can use a loop to iterate through that array and get the output. Okay, right. But in C sharp, arrays had a fixed length. So therefore, uh, we need to get, we have lists. So lists does not have a fixed length. Then we have dictionaries. Dictionaries is to keep uh, values in like key value pairs, right? So, right. Then we have two other data structures. Those are stacks and queues, right? Um, so, what is a stack? So, in a stack, uh, like we have last in, first out, right? Stack. Uh, um, students was void new stack of digital type, right? So to add the value, the stack we use push method, right? We use okay. 10. So now this is like a stack of cards, right? So um, using pop method, right? So pop we can get the pop. So this will give me the first element. Let's create a new class for it person. Then um, we know a class has a attributes and methods. Like what I want to do here is I want to create an I want to calculate this person's age. So initially I will keep his birth date and uh, I want to pass uh, pass an year, calculate age for that year, right? Right. Okay. So uh, uh, let's define his age, birthday. It's it, birth year as let's say uh, okay, right. Now I need to have a method to calculate his year, right? Calculate his birth, uh, calculate his age. Okay? Calculate age. And it's telling me method must have a return type. Okay, this method's return type will be an int. So this will take current year, current year as a parameter, and I want to return this age as current year minus birth date, right? Right. So um, let's create an object from this class. So person, let's say I want to create an object called person from this person class. So new person, right? Right. Then uh, I want to calculate his year. Person dot calculate dot calculate calculate age. And I want to pass some year, like let's say 2025. Okay. I'm getting an error, right? Person can be inaccessible due to its protection level. Right. This is the first concept of object-oriented basic. That is encapsulation. Right? This is encapsulation. Uh, so encapsulation means the concept of allowing access, right? So, right, we have three, uh, we do it by access modifiers, right? We, we have three access modifiers like called private, public, and protected, right? So, if the variable or methods access type is public, it can access from anywhere. Okay. So if it is private, it can only access within it, its class, right? It can only access within its class. If it is protected, it can be accessed by its own class and its package or its subclasses, right? Okay. So uh, so that's encapsulation, right? Uh, Encapsulation is basically about controlling access to the data using access modifiers, right? There is three access modifiers called private, public, and protect. So here I want to access this. Uh, uh, I want to access this uh, calculate age method outside its class, right? Outside its class. So, um, what is the uh, access modifier uh, should be here, like for the calculate age method, but should be the access modifier to access it from this class. Okay? So it has to be public, right? Public, 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 right? Then I can uh, calculate, I can get his age. Say int age as right? Then I can console console dot pipeline age. Okay. right? So, so let's run this and let's see the out. Uh, see this string console read. Okay. So let's see the output. I get as 27. Okay. So, yeah, that's encapsulation. So, what do we mean by encapsulation? It's about controlling access to the uh, attributes and methods of the class. We do that using three access modifiers called private, public, and protected. Okay, so that is encapsulation, right? Hope you understood it. Then initially he has a like birth year, right? So rather than doing it like this, I want to create multiple persons like from this person class and set their birth year when the class is getting created, right? Rather than doing it like this, I want to set his birth year when the object getting created. So here a new object is getting created from the person class. So when this happens, I want to set the birth year. Right? To do that, we have a special method called the constructor of this class. Okay, that's called the constructor of the class, right? So uh, a constructor will have the same name. The constructor method save will have the same name of the class, right? So let's create a method called person, right? Person. This method will get called when the object is getting created, right? Right. So I'm saying so this method will take an integer as birth year here, and I want to set this class's birth year as the birth year, right? So this is we call it as constructed constructor. So this method, its function will get called when the object is getting created, right? Right. This give me an error. Person does not contain a constructor takes zero arguments. Person does not contain a constructor that takes zero arguments. So this person, this constructor by default has a private access modifier. So we need to make it public. Public. Right. Now, uh, there's no argument given the corresponding to the formal parameter birth year. Now I want to pass the parameter. Let's say I want to create two persons. Let's say Kamal, his birthday is 1998. Then I need to create another person for control. Amal's birthday is right. Now, uh, let's calculate these two persons' age for 2025. Right? We want to calculate Kamal's age, say current year is 2025. Then, uh, yeah, let's run this 27 and 30, right? So, this is the constructor. First, we learn about any calculation, then constructor. Constructor is a special method or function which get called when the object is getting uh, created or instantiated, right? Right. Encapsulation. Then we have inheritance. Inheritance is basically creating subclasses from the parent class, like creating derived classes from the base class or the parent class. So the derived class can inherit, uh, derived class inherits attributes and methods from the base class, and it can also have new attributes and uh, methods, new attributes and methods, or override existing ones. What do we mean by that? Let's say we have a class as person, and we have two persons, right? A student and a teacher, right? Student will have a birth year and a teacher will have a birth year. Then the student will have a, let's say, student ID, and the teacher will have a teacher ID, student, student, right? It inherits from person, so it will have a, polymorphism was basically having different forms, right? We had a parent class per person, and we had two subclasses, right? Teacher and student. Teacher has a different, like I wanted to print uh, different information for uh, student and wanted to print different information for teacher. That's the different behaviors, right? So to do that, it's about its polymorphism, right? We achieved it by override, by method override, and uh, so to method override. So the the parent class method need to be uh, a virtual method, and we can override that method, right? That's basically it. Yeah, yeah, and I have created now a student and a teacher, right? And let's create another uh, class from the person parent class as well. Person, I need to create a person, new person. It is taking birth and name. Okay, let's say uh, 1995. Name is say Lim. Lim. So I want to print each one's information. Right. So first I'm printing screen for this. Okay. Okay. Here I want. Okay. No. And teacher got yesterday info. Okay. Right. Yeah. So let's run this and let's see what's the output. Yeah. Right. First, info about the person. Sukun is a student. Kamal is a teacher. So what happened was it got override. Right. Person's display info method got override for student and it could override for teacher. Right. So we achieve polymorphism. Polymorphism is basically about having different forms, right? Different forms means they have behaviors, right? So here in this case, I want to show different information for student and different information for teacher. So I achieve this by virtual methods and overriding them. Okay, so that's polymorphism. Yeah. Okay. Um. Yeah. Now, we have learned about constructor. Uh, Inheritance, polymorphism, and encapsulation. Last one is abstraction, right? Abstraction is basically about finding complex, uh, only showing the uh, so abstraction is about hiding complex uh, uh, implementation and only showing uh, the this is like the abstraction, like so affiliate age and in the subclass. So when we are calling it, we can straight away uh, call that method. So uh, right, so that's like abstraction. Like it is about hiding complexity and only showing the feature. Like it's for real world example, it's like let's say in a car we know how to brake. Right? We need to push the brakes, right? But we don't know about the underlying. There's no need to know about that. Like that's the idea, right? And we can make a class abstract, right? We can create a class abstract. If it is an abstract class, we can't create objects from that class, right? So then I'll make this class abstract. So if it is an abstract class, I can't create straight away, I can't create objects from that class, right? Right. So in from an abstract class, I can't create objects. And uh, abstract classes can have methods. can have methods. Those are like concrete methods and abstract methods. Like if it's a concrete method, uh, it can have the functionality, and we can have methods like let's say I want to uh, uh, explain. So I want to display generation, display generation. Um, right? It does not. Right? Let's make it public to public, and let's make it abstract. Right? So it will have a void return type. That means it will not return public void abstract class or abstract method. Right? Right. So this is a method without any implementation. So abstract classes can have concrete methods and abstract methods. Concrete methods have the functionality, and abstract methods does not have the functionality. So it we need to define it. Uh, so we need to give the implementation. Student does not implement the abstract member display generation, right? So we have to give the implementation in the subclass. So uh, we can we do at the override event. Okay. Presentation. Let's say if um, in birth year greater than birth is inaccessible. Let's make it vector to access in the subtask. Okay. Birth year is greater than 2000. Let's uh, is in C. If else, not in C. Okay, right. So we can do this for uh, teacher as well. In C, right? Okay. So since this is abstract, I can't create objects from this class. Okay, right, right. So, uh, right. So now let's say generation to display generation. Okay. Yeah. Right. Now let's run this and see the output. Student is Gen Z, teacher is not Gen Z. Okay. Yeah. So that is the object-oriented principles. Um, constructor gets it's a special method that get called when the object is getting created. Then um, we have encapsulation. Encapsulation is like the controlling the access. We control access with three uh, access modifiers: private, public, and protected. It is protected, we can access it from outside the class, and if it is uh, and from anywhere, if it is protected, it can only access from within the class and from its subclasses. And if it is uh, the public, it's only accessible within the class, right? And we have then we uh, learn about uh, inheritance. Inheritance is basically about creating subclasses from the parent class, right? So the subclass will have all the uh, attributes and methods of the parent class, and it can have additional uh, methods and attributes and properties as properties and methods as well, right? Then we learn about uh, encapsulation, uh, 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 inheritance, then polymorphism. Polymorphism is having different forms, right? Different forms means like in this So thank you very much for joining, and let's meet next week. So thank you very much.